I'm Anil Kumar. In this video, I'll discuss about periodic functions and their properties. We'll consider these topics. The first one, we'll talk about what is a periodic function. Then we'll discuss key features like range, period, equation of axis, and amplitude. We'll interpolate information from the graph. We'll also predict by extrapolating the information from graph. We'll sketch graph from given conditions, and we'll also find equation of periodic function from the graph. So that will cover most of the things which you need to know about periodic functions. Now, first thing is, what is a periodic function? So any particular function whose graph repeats at a regular, that is important, at a regular interval. Right, so that results into a periodic function. So when we talk about graph, at that time, we are looking into a relation between two functions, two variables. One is independent variable. Normally, we'll write independent variable as x and the dependent variable as y. Right? So when I say that a function is periodic, that means it could be kind of like this, for example. So we could have a wave like this, right? So that kind of wave, right? So, and keeps on repeating. So here, let me make a scale to just understand it better. Let's say this point here is 3, this is 6. So what we're trying to say here is that the peak of this particular graph is, let's say, 5 units, is achieved at when the x value is 2. I'm not putting any units here. And the graph repeats after every 3 units. Let me write, okay, x as time in seconds, and let's say y is height in meters. Okay. So in this case, what you notice here is that the graph repeats after 3 seconds. So that is called the time period. So the regular interval of 3 seconds, right? That is called time period, which in this case is 3 seconds. Now the maximum value is 5. And the minimum is 0. So what we have here is that the maximum is 5 meters and minimum is 0 meters. So that gives you a range. So we can say the range of the graph is all the values of y which are greater than or equal to 0 and are less than or equal to 5. Do you see that? So these are a few things which we can always come up with. Now, any periodic function, we also have a term which is called axis. Now, axis is midway between maximum and minimum. So it is always maximum plus minimum divided by 2. So in this particular graph, the axis will be between 0 and 5, midway, which is around 2.5, right? So I could draw this line as axis. So in our example, the axis is going to be equal to 5 plus 0 divided by 2, which is 2.5. So this will be 2.5. We could write this as y equals to 2.5 as the equation of the axis, correct? So these are few terms which are very important to understand. So these are termed as the key features for any periodic function. Now here we define one particular unit of graph which repeats. For example, this unit of graph which is repeating is called one cycle. So this particular thing which repeats is called a cycle. So a cycle is the unit which repeats. Right, so that is one more important term to look into. Now, when we say repeat, it means that exactly same has to occur each interval of time, correct? You will also notice that if the time period is 3 seconds, and for the first time, let us say the maximum is at 2 units, then when will the next maximum be? You could extrapolate, right? So we can say that the maximum will be at 2 plus every time the cycle repeats, which is 3, right? 3 times n, where n belongs to natural numbers, correct? So that ways we can actually, from the graph, write what is going to happen after some time in this case, right? That is extrapolation. Perfect. So that is the part of predicting by extrapolation. Interpolation, we just saw, we could actually find when will it be 2.5, right? So you can read it from the graph, the values, when it will be 2.5. Now from the graph we could get some values. Now we'll move forward and take some examples to check if we really understand all what we did so far. But as far as the periodic functions are concerned, it is important to note that periodic functions could be of any shape, not necessarily sine or cosine waves. Perfect. With this, let's move on and do some test questions. Okay. So the very first question is talking about periodic functions themselves. We have 4 examples. So you need to tell me which ones are periodic, right? So which are periodic functions? You can pause the video and answer. Clearly, here the pattern is kind of decreasing. Nothing repeats, so this is not periodic. Here also, it is kind of increasing, not periodic. This clearly is periodic. How about this? Now here what you see is that it is periodic. It always copies the same thing, or the same graph repeats after a fixed interval of time, correct? Now as an exercise, what you can do is that you can find what is the period here for this particular function. You can find maximum and minimum values. You can calculate excess of symmetry. Correct? So you can find all these values for the given graph. Correct? You could interpolate when is y value equals to 2, for example, right? You could do that. So likewise, you could do many things with a given graph. So we are going to now explore these things with some graphs. But you can do with these graphs also. Okay, let's move on. So now we have a graph and we will calculate the key features of a given periodic function. As I was saying, periodic function could be non-sinusoidal as shown here. Now we'll talk about the key features, which include range, period, equation of axis, and amplitude. Now range means what y values. So range means extent of y values, the dependent values. Is it okay? So in this particular graph, we can see that the maximum is at 2, right? And the minimum is at -4. And therefore, and it is continuous in between. And therefore, we can say that the range is from -4, both included, to 2. So that is the change in y value. So with the range, we checked y value. Is it okay? So all this is the range. So it is between these two values, as you can see. Now what is a period? For a period, we identify a cycle. So for a period, let us identify a cycle. So if I start from here, I can say, well, this is my cycle and it repeats after this. So that identifies the period. So from 0 to this value, which seems to be 3, is my one cycle. So this is one cycle. Do you see that? So we say that the period is 3 units. If I write seconds here, then it becomes in seconds. If I write meters here, then y value becomes meters. Otherwise, you just write units. So in this case, we can say period. If I write seconds, we say period is x equals to 3 seconds. Is it okay? That is the period. So after every 3 seconds, the graph repeats. Equation of axis. Axis is the medium value. So you do maximum plus minimum divided by 2 to find the axis. So for us, it is 2 plus minus 4 divided by 2, which is minus 2 divided by 2 and minus 1. So let me sketch the axis line now. It is at minus 1. So this is 1 for minus 1 for us, right? So that becomes the axis for the graph. Okay, so that is kind of the axis. Is it okay? Okay. So that becomes the axis for the graph. Amplitude is how far away is maximum or minimum from axis. So amplitude is distance from axis. So in our case, the distance from axis is this distance from minus 1 to 3. So that distance is the amplitude. Do you see that? So we can say that the amplitude for the given graph is, we could also find amplitude by difference of maximum minus minimum divided by 2. So we could do maximum minus minimum divided by 2 to get amplitude. Let me do it here. So maximum value is 2 minus minus 4 divided by 2, which is 2 plus 4 divided by 2, which is 6 divided by 2, which is 3. So as you can see, the amplitude is 3 and the units we have taken as meters. Amplitude is always a positive value. Okay, so that is how we can actually find all the characteristics of a periodic function from the graph of a periodic function. I hope that's clear, right? So let's move on and see what is interpolation. Interpolate information from graph. The word interpolate means read from in between. So from the given part, in between. Given values. That is kind of important, right? Extrapolate will be, you may have to figure out by extending the graph, right? So now let us see the question. The question here is, sawtooth wave is shown in the figure. Determine the time when height of the wave is 1 meter in the first 3 seconds, right? So height in meters is given to us. Time in seconds is given to us. First 3 seconds means, so the units are, this is 2 for us, right? So this is like 1, peak at 1, and this is 3. So this is 3. So first 3 seconds means up to here. So determine the time when the height of the wave is 1 meter in first 3 seconds. So at 1 meter, you can always draw a horizontal line. So that is how you're going to do. So you draw a horizontal line. So once you have drawn a horizontal line at 1 meter, then see where it intersects. So these are the points where it intersects the graph. So you can read this, the independent values you can read. Now that is beyond, so we are not considering this one. We are interested in first 3 seconds. That means from 0 to 3. Is it okay? So up to here. So we have few values which we can read. Now this graph is not so clear for you. However, it seems to me that this value here, because this is 2, this is 1, this has to be half, right? So 0.5 or half, and this is 1.5, right? It is 1.5, and this value here is 2.5, right? So it is now, as you can see here, what we can do, we can read the first two values and then add the time period of 2, right? So you can see half plus 2 is 2.5. It makes sense. So it gets here as 2.5. So that is how you get your values. So the steps involved are that draw horizontal line, which is y equals to 1, find points of intersection, with graph, and then read independent values. In given domain, right? Okay, so doing all this, what do we get as our answers? So the 1 meter height is at which time? It is at half second. You can write 0.5 seconds. You can write 1.5 seconds and 2.5 seconds. Is it okay? So that is how you could answer such a question. So I hope the steps are absolutely clear. Now let's look into predictions. Now we are going to predict by extrapolating the graph. So as you see here, we have given you a graph for about 12 seconds, right? And what do we want? When will the distance be 4 units between the time 20 and 25 units? We want distance of 4. So if I kind of sketch this line, we know the distance of 4 units is achieved when, let's try to figure this out. Well, initially it is at this point and here. Okay, so that gives you a value which is, here it is close to 1, and in this case it is close to 2.5. So these are the two values at which the distance is 4 units. Do you see that? Now, but these values are between 1 and 3. We want values between 20 and 25. How do we get that part, right? Now, for getting that, what you can do is you can find time period. That will give you when it repeats. So as you can see, one particular cycle can be defined as, starting from here if you see, ending there, right? So that is one cycle, which is 4 units. So it repeats after every 4 units. So first cycle, second will be 8, third, fourth, fifth cycle will end at, so 20. Do you understand? So basically, first cycle in 4, so there will be 5 cycles in 20. So it is a 6th cycle, which is after 20 units. Do you see that? That means we should add 5 times 4 to this. So we should do, since time period is 4, right? So 5th cycle is ending when? Ends at 4 times 5, which is 20, correct? So we can add 20 to these values, and therefore we get our answer as the time should be 20 plus 1, 20 plus 2.5. Do you see that? That is first. And then 24, because it is every 4 cycles, correct? So whatever you get 4 cycles. So next will be 24 plus 1 and 24 plus 2.5. So if you calculate, you find that there are 3 times when it is within the given interval. So 20 plus 1 gives you 21. 20 plus 2.45 is 22.5. This is 24 plus 1 is 25. And here it is 26.5. Now since this is out of our range, we'll remove this. We have to go up to 25. Correct? And now we can write down our answer. So the answer will be 21 units, 22.5 units, and 25 units. Do you understand? So that is how you're going to write down the answer for such questions. This is what we call extrapolation. You're predicting what will happen, right? When will it be 4 distance away? So I hope that's absolutely clear. So let's move on, and now we'll discuss how to sketch graph from given conditions. So the question here is, sketch the graph of a non-sinusoidal periodic function with a period of 20, an amplitude of 6, and whose equation of axis is y equals to 7. So let's write down. So one thing is, it should not be sinusoidal. Is it okay? That's first condition. Second, periodic with period of, so time period equals to 20. Amplitude, let's say A, M, P, L, I, T, U, D, E is 6. Axis is y equals to 7, right? So that is the information given to us. So let's draw the independent x-axis and the dependent y-axis. Since we are looking for amplitude of 6 from the axis of 7, do you see that? So the first step is sketch the axis 7. Let's say this is your y equals to 7. Do you get it? This is y equals to 7. First step is do this, axis. This is number 1 step. Number 2 step will be go for the amplitude. Go for the amplitude, which is 6. That means this. Here the value is 7. You go plus 6 and minus 6. So if I take away 6, I'm here. That is the minimum value. And if I add 6, I'm somewhere there. Somewhere there, right? So basically, this line will be y equals to 7 plus 6. And this will be y equals to 7 minus 6, which is 1. And this is 13. Do you see this? So this point will be at 13. So we got the amplitude of 6. Time period of 20. And we have to make a non-sinusoidal function. So what you can do is just create a wave which is not sinusoidal. So okay, so if I begin like this, I could do like this. Do you see that? And it goes. So that is how you can make your wave. Now the question is, you have to ensure that the time period is 20. How do you ensure that? So that means you have to identify one cycle. Now in this case, one cycle begins from here, ends there. So that portion should be 20. Do you understand? So this intersection with the axis is next 20. So that is how we make a wave which repeats after every 20 units. Do you understand? Period of 20. So this is your x, which is period of 20, and that is y. Do you see that portion? And so that is one cycle which actually repeats. So I hope that makes sense. That is how it can be answered. Perfect. So let's move on and take up the last question of this particular video. Now here we need to find equation of a periodic function from the given graph. So strictly speaking, all what we have covered here is all what you need to know about periodic functions, right? Now how do we find equation from the given graph? So the steps are, first find what is maximum value, then find what is minimum value, and then you could find axis as maximum plus minimum divided by 2. You can find amplitude as maximum minus minimum divided by 2, right? And you can find time period by identifying a cycle. So in this particular case, one cycle means we are starting from minimum. That becomes the cycle. Do you see that? So we'll identify this as one cycle. So in our case, the cycle identified, it repeats, right? After 8. So time period is 8 for us. Units are seconds. Now units are important to write. Now maximum is right there, and minimum is this place, right? So the maximum value for us is 5, the minimum value is 1, correct? So now we can do all the calculations and get the equation, right? Okay, so axis, so it is AXIS, is 5 plus 1 divided by 2, which is 3. So at 3, we can draw the line of axis. You see that? That becomes the axis. Amplitude is also the distance between axis and maximum. So you could calculate like this, 2 units, right? Or plug in these values, which is 5 minus 1 over 2. 4 divided by 2 is 2, correct? So that is the axis, amplitude. Now, what? You have to give an equation. Now, this function starts with a minimum, so we can say it is minus cos x. T is the value here, so independent variable is t for us, minus cos t. However, the time period is 8 seconds. Normally, for a cos wave, it is 360. So we get this as 360 degrees divided by 8, correct? That becomes the time period t. Plus the axis, it has moved up by 3 units. So that is how we could write our equation y equals 2, correct? You could always divide this by 8. 8 times 4 is 32, and then, so you could write this as minus cos 8 times 4 is 32, so 40 means 5, right, t. So this is in degrees, plus the axis 3. So that is how you get your equation of the graph. Perfect. So we'll learn more about this later, correct? So in general, sinusoidal functions could be written as y equals to a times, amplitude I forgot to write. Amplitude is 3, so let me insert it. So the amplitude is 3 here. So this is the amplitude. Okay. So a times cos or sine, you could use any depending on the type of function, right? Normally we use sine. K x minus p plus q, where q is the axis, a is the amplitude. K depends on time period. So K is 360 degrees divided by the time period, right? That is what we use, 360 divided by time period. It's kind of important to know this. K is 360 degrees divided by time period. P is the phase shift and Q is the axis. So we'll learn about phase shift in the next part of the video, right? Here, since we know the properties, cos starts with negative, means it has been reflected. That's why we use negative here. Does make sense to you, right? So that is how you could actually do equation or write equation from the given graph. So I hope that gives you a good understanding of periodic functions. This topic will now be dealt in more details in the next unit. Feel free to write down your questions and your suggestions. And if you like and subscribe my videos, that'd be great. Thanks a lot and all the best.